Okay, let's take a look at the covalent bonding. Okay, first let's take a look at some features of covalent bonding. Okay, the first one, covalent bonds results from sharing electrons between two atoms. Right, covalent bond is a electron bond. Okay, two electron pair in which the bonding atoms share valence electrons. Okay, valence electrons. A molecule is a compound held together by covalent bonds. Okay, and next, in a formula, when we draw a molecule formula, you can see a solid line between two atoms, okay, that represent a covalent bond. Okay, and you can see this water molecule. You can see the solid line between hydrogen and oxygen. This is the covalent bond between hydrogen and oxygen. All right. In forming a covalent bond, atoms share electrons to attain electron configuration of a noble gas. Okay, we call this a octet rule. Next, let's see. Sometimes multiple covalent bonds can be formed. Okay, double bonds means two pairs of electrons between two atoms. Triple bonds, three pairs electrons between two atoms in a molecule. Okay, those multiple bonds are formed in order to meet the octet rule for the main group elements in periodic table. Okay, and then we can take these two molecules here. You can see that the double bond between two carbons. Okay, and this one has a triple bond. Okay, but the carbon surrounded by 4 bonds in total. Okay, and this is the 1H, 1, 2, and 2 here is total of 4. Okay, this one is the same. Okay, because only have 1H bond to atom, so require triple bond between the two carbon atoms. Okay, this is the multiple bond. Okay, so when we form a covalent bond, we follow this octet rules, but there's some exception. Okay, the first one is the hydrogen has only one electron. Okay, one electron, so only have one shell, and so the noble gas electronic configuration is helium. Corresponding noble gas is helium. Okay, so helium has 2 electrons. Okay, because this one shell, first shell, only one shell has the s orbital. Okay, s orbital has two electron maximum. The second situation is boron. Okay, boron is a special element. It's the metalloid. Okay, it's on the A3 group in the main A3 group in periodic table. It's a metalloid. Boron has 3 valence electrons. Okay, and therefore only be able to share 3 electrons with other atoms. Okay, the maximum of electrons on the outermost are 6, but not 8. Okay, this is the special case. Boron is a metalloid, but not the metal. Therefore, they cannot just lose the valence electrons become a cation. Okay, this is a boron. Okay, instead of to form ions, actually they form covalent bond, sharing the electrons with other elements. Okay, this is the boron. The third exception is phosphorus and sulfur. Those elements have empty d orbitals, so they can have the valence electrons more than 8. Okay, some cases they can have valence electrons more than 8. Doesn't really follow the octet rule. Okay, the last thing we talk about is resonance. Okay, resonance. Let's say the polyatomic ions have 2 or more valence electron arrangement. Okay, in other words, the resonance structure are 2 or more Lewis structures having the same arrangement atom, but different arrangement electrons. And let's take this example, this carbonate. Okay, carbonate has the same arrangement atoms. Okay, we have 2 forms here, but the electron arrangement are different. Okay, you can see this one. This carbonate has 1 negative charge here, and this oxygen has 2 lone pairs and a double bond. This oxygen has 3 lone pairs and a single double bond. Actually, the next charge is on this oxygen. Okay, and then you can see the electron redistribution. Okay, in this case, this lone pair or this lone pair can come to between carbon and oxygen and form a shared pair. Okay, become a bond between carbon and oxygen, and this shared electrons can become a lone pair. Can be a lone pair of this oxygen. Okay, this is what happened. Then they become to this this form. Okay, and the double bond formed here, and this double bond break up and become single bond. Then the paired electron between this hydrogen and this oxygen come to the lone pair. Okay, and they become this. Then this form can come back, and this lone pair can come back to the location between oxygen and carbon, and this lone pair can come to become this shared pair can come to become lone pair of this oxygen and come back to become this form. Okay, this is called resonance. Okay, structure. Okay, this example is this structure is bicarbonate. Bicarbonate. Okay, they have only 1 negative charge. Okay, so the last thing, let's take a look at the naming covalent compound. Okay, unlike ionic compounds, okay, prefix are added to show the number of each element in a compound, in a covalent compound. For example, this nitrogen oxide, okay, this is a covalent compound. We have 2 nitrogen here and 4 oxygen, so we have to add prefix di ahead of nitrogen and a tetra ahead of oxide. So the name, correct name should be dinitrogen tetraoxide, right? This is the example, all right. And also we have the ionic compound here. We draw this just to show the difference. This is a sodium oxide. Okay, you can see we have 2 sodium iodine. Okay, so in this ionic compound, we just call the sodium oxide. We don't say disodium oxide. Okay, that's the difference between ionic compound and the covalent compound. Okay,